All right, now let's talk about actually testing a real card. Let's go look at the card wall again. GitHub.com mask project. Okay, here's our front page again. Let's look at projects, mask node. We've done this before. Here's the card. Oops, what just happened? You may not have seen that actually. I put another window up over this one, but you may not have seen. If I don't know how the screencasting thing works. So if you were doing this yourself, you would be taking a card out of awaiting quality assurance and moving it into quality assurance in progress. But one of the reasons I'm making this video here is that we don't really have any testers yet. So I'm going to grab a card from done this iteration. Here's card 146, here's our card 161, 143. We'll try 186 because I've already sort of taken a look at this one. Remove dead nodes after a decent interval. So here is here's the description. Sorry, but I'll read this. Dead nodes are kept in the neighborhood database to ensure that they're not accidentally added back in while processing gossip from nodes that don't yet know they're dead. Arrange to have them expire from the neighborhood database after enough time has passed that we can be reasonably sure gossip about their newly dead state has propagated throughout the network. Suggestion, don't make a special, I don't care about that. That's to developers. Doesn't have anything to do with testing. So you would be if you had pulled this card, you would need to test this behavior. There's an example of something bad here that doesn't show. So I'll just warn you about that, and we'll encounter it together later. But if you think about this, imagine that you saw this card not here at the end, but you saw this card earlier at the beginning of the card wall in a grooming meeting or a design meeting or something, and it was your job to figure out how to test this. How would you test it? Well, it seems reasonable that you would use TNT to start some nodes. You wouldn't actually have to run any data through those nodes for this. You just use TNT to start up nodes. You'd look at the neighborhood to see how it was connected in the database and in the gossip, and then you'd kill one of the nodes and look and see if there was any more gossip, if killing the node produced gossip. And if it did, you'd look at the gossip and see if the dead node was in the gossip, and if it was, what was connected to it, and look at the databases, and look at a few databases and see if the node was in those databases. That sort of thing. And if everything happened okay, then you'd say, oh, all right, this card is approved. And if you noticed problems, then you'd move the card back and put a comment on it saying, no, I noticed these problems. So let's use TNT to take a look at this. So let's start up TNT again. All right. We'd like to run in Docker. Let's start up 7 nodes again. Well, actually, that's 7 containers. That's just the containers. We haven't started the nodes yet, but let's go ahead and start them. Okay, here's something we haven't done yet. Let's take a look at inspect. Let's inspect. Oh, node 0 is handy. Inspect will, well, I'll show you. It says it just scanned through the log for node 0, and it says there are 17 logs about the neighborhood database changes for Bulbasaur. Which one do you want to see? Usually you want to see the latest, but you can take a look at any one if you want. I want to see the latest, so I'm going to say 17. Now, I don't know if I don't know how that's set up, but I'm going to show you the window that just popped up. So here is the neighborhood as it as node 0 sees it. Here is node 0. You'll see it's on IP address 2. And you'll also see things like how node 0 knows the IP address of this node because it's right next to it, this node because it's connected, this node because it's connected, this node because it's connected. It does not know the IP address of this guy because it's more than one hop away, or this guy. So just so you know, this A and R, they have to do with consume only and originate only. This V2 means this is version 2 of the information about this node. There was a version 1, but it's been superseded. Here's version 4, version 3, version 4, and this is the first few characters of the public key. It's not the whole public key. It's just, I guess it's the first 8 characters of the public key, and then if we know the IP address and clandestine port, it's listed here in this third line. So as you can see, these are all connected up with double connections. If you kind of squint, you can sort of see how this works out to be a bridge girder shape. This is one end of the girder with just two neighbors. This is the other, also with 2 neighbors, and it's connected. The very end is connected to something with 3 neighbors and something with 4 neighbors. Here, this guy is connected with something with 3 neighbors and something with 4 neighbors, and everything else has 4 neighbors. So we'd have to like move this around and stretch it out a bit, but it'd turn into a bridge girder if we looked at it. We could look at this from another vantage point, but instead of that, let's try killing off, what is this, node 1? Let's try killing node 1 and then seeing what happens. Okay, here's the TNT window again. I do not want to see any more neighborhood database neighborhood databases right now, so I'll hit enter. It says, okay, so what do you want me to do? I want you to kill node-1. And I know it's node 1 because the IP address was 3, so that must mean node 1 has IP address 3. So there we go. Now let's take a look at inspect node 0, just because node 0 is handy. Ooh, look at that. 20 logs about neighborhood. Remember how it was 17 before? So there was, they gossiped about that kill. That is something, that's something to mark down and say, okay, well, we killed a node and there was gossip about it. What does that gossip look like? Well, let's take a look at, we're not looking at gossip right now, we're looking at databases, but let's take a look at 20th database version of the database. Okay, let me switch you over to that window. Okay, here we are. Here's node 0. You'll see that node 1 is, well, maybe you remember from when I was showing it to you before, but I've still got it up here where you can't see. So I'll tell you the public key for node 1 is WJYX. In other words, this is node 1. So you see node 1 is still in the database, but nobody is acknowledging that node 1 is its neighbor. Node 1 is still in the database, and it still is claiming that all these are neighbors, but nobody else is acknowledging it as a neighbor, and so of course no traffic, at least not here from node 0. No traffic can go through node 1 because none of these arrows are bidirectional. But it's still in the database. It hasn't been removed from the database. The card said after a decent interval. Maybe the issue is just that the decent interval hasn't elapsed yet, but we can see that it's still in the database. But this makes me wonder, what did the gossip look like that made this happen? So let's go. Let's see. Actually, let's take a look at node 8. I'm sorry, node 6, IP address 8, which is far enough away from node 0 that node 0 doesn't have its IP address. Let's take a look at that. Okay, so we're done looking at stuff for node 0. Let's inspect node-6. Only 6 logs. Which one do I want to see? Well, I want to see number 6. And here it is. Just a moment. So the gray one here is node 6, and we see WJYX, that's node 1. Same thing here. Even though node 6 here is nowhere near the node 1 that blew up, or that we killed, it still knows about it, and it still knows that it's not to be used. So at least that part's okay, but node, it's still in the database. Let's see if we can figure out how node 8 found out about this. Just a moment. All right, we're done here. Let's look at, well, did I say node 8? I meant node 6, IP address 8. I do that a lot, I'm sorry. Whenever there are only 7 nodes started, node 0 through node 6, so if I say node 8, I'm probably talking about node 6. Okay, so let's see how we have an outbound command, an inbound command, and an inspect command. Inspect shows us the condition of the database, in the neighborhood database in a particular node. Inbound and outbound show us gossip that is either leaving that node or arriving at that node. Outbound is leaving and inbound is arriving. Gossip looks a little bit different from a database. Let's take a look at the gossip that was inbound to node 6. Inbound node 6. There are 15 logs about gossip messages received for Squirtle. Again, what happens here is that TNT goes and runs through the log for node 6 and identifies all the messages about that have to do with incoming gossip, and it's found 15 of them. So it says, which one do you want to see? Well, I want to see the latest one, so I will say 15, and I got a pop-up here. Let's go take a look at that. All right, here's node 6. Oops. No, this isn't. Gray means something different here. So here, the last gossip that we received was gossip from node 3. It's IP address 5, so that's node 3. Gossip 2, node 6. So whenever you see a gossip diagram, you'll always see these two things here somewhere that are connected by an arrow with a hollow head. This is where the gossip came from. This is where the gossip arrived. So over here, this is what's in the gossip itself. The one that's gray is where the gossip came from, and this may look a little weird. This is where the wait a minute, is that right? Yes, this is where the gossip arrived. The fact that it doesn't have any border around it means that there's no actual information about this node in the gossip. There's information in this node that it has this node as a neighbor. but it doesn't actually, I mean, for this node, for example, there's information about the flags that for incoming and consume only. There's information about the version. There's information about the public key, information about the IP address and clandestine port and so on. There's a bunch more information that doesn't show up here too. But one of the pieces of information that's in this node is the fact that it has this node as a neighbor. Which is why you have an arrow out to this node. This guy has no circle around it because there's no record, no specific record in the gossip for this node. The reason for that is if you're gossiping to me, if you're gossiping your database to me, your database must include a record for me. Because you have to know about me to gossip to me. But you're not going to tell me anything in the gossip. You're not going to bother telling me anything about me because I already know everything about me. As a matter of fact, I know it better than you do. So there's no need to waste the space telling me about me. So you're going to leave me out of the gossip that you send me. So that's why there isn't any information about this node in this gossip. However, if we look for that node that's missing that we killed, WJYX, you'll notice that it's not there. It's not there. It's gone. We're not gossiping about that node. And everything that we are gossiping about has a double edge. Well, except these arrows aren't doubled, but that's again because you're not telling me anything about me. If you were telling me about me, one of the things you'd tell me about me was that I had an arrow to here and I had an arrow to here, but that you're not telling me that, so because I already know that, so it's not in the gossip. So what we're seeing is the node that was killed is gone from the gossip, but it's still in the database. So what does that mean? Well, here's the issue that I was talking about before. The fact is, we decided when we were doing the development work on this, we decided to just leave it in the database. Because the thing that was really killing performance was not that the databases were getting so big that memory couldn't hold them anymore. The thing that was killing performance was that the gossip messages were getting so full of dead nodes that they were 200, 300 nodes long, and it was just really, really unwieldy. So we figured, look, as long as we don't gossip those nodes, it doesn't really matter if they stay in the database, and if they do stay in the database, then that's we do get the benefit of if we get an old gossip message or a message from a node that hasn't sent gossip in a while or received gossip, and that node thinks that the dead node is still alive, it doesn't show up in our database again. We've already got him in there, and we know that we don't have a connection to him, so we're not going to revive him accidentally because of the version number. So just to keep the version number in the database, we decided to keep the node in the database, but the card doesn't say that. The card should have been changed during development to say that we made that decision. And if we had testers, the testers would complain and say, hey, I noticed that this card doesn't do what it says it does. And then we would have had the argument, well, do we make the card do what it says it does, or do we make the card say what it actually does? I think the right answer there is to make the card say what it actually does. But what I want to get from this is that if we had testers, we would have a defense against this. Now, after this video is done, I'm going to go change that card because it's a bad example and I want it fixed, but it's another reason that we want testers. Okay, so I guess that's about it for this for episode 1 of Testing Tools for masq. In the description, you'll find a link to the community Telegram channel for masq. If you're interested in being a masq tester, if you're on Telegram already, just come to that channel and tell somebody, post a message saying, "Hey, I want to be a mask tester," and we'll get you set up. If you don't have a Telegram account, go to the URL and make yourself an account. We would love to have you. We look forward to seeing you, and if you've stuck with us for this long, thank you for watching the video. Goodbye.